Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 76, maximum score of a node sequence. So this one is what I could say pigeonhole principle, and I will go over this in a sec by, let me set up my drawing pad real quick. Ooh, whoops, one button. Bang on the keyboard really by accident. But yeah. But I think the principle is actually not that. I just to kind of also give, because I like to talk about my thought process as well. I think I knew this one immediately, or I don't know that I knew this one immediately per se, but because I think they kind of let's go back a little bit for a second. They kind of hit the length of 4 thing like just right in there. I don't know how long I spent. It wasn't like. I still spent some time just trying to optimize this in general. I was like, oh, that's the longest or the max symbol path, right? The max symbol path is kind of what this algorithm would ask, except for that it's a length 4. So then that makes things more tractable. And yeah, and because the first thing I looked at is also n, where n is less than 5 times 10 to the 4th. So I knew that it has to be a linear DP or faster, right? Like it has to be linear. Like if it was DP, maybe I was thinking if it was dynamic programming, maybe it's n squared, but in this case, n squared would be too slow. I don't know if there's an n squared dynamic program, by the way. But I'm just saying, like, if there was one, generally sometimes it's like n squared e, right? So, and that's like a fast one. So I was like, okay, so it has to be a little bit more clever. And I was just thinking a lot along it. But once I saw that the sequence is of length 4, I was like, oh, I think I know how to do it. And then I spent honestly a little bit too long proving it to myself, and just making sure to myself more than proving per se. But yeah, and then the idea is, let me, yeah. The idea, maybe I don't like this one, hang on. But yeah, the idea is that let's say you have a couple of nodes, right? Yeah, and they all have weights and stuff like that, right? So I'm just drawing way, I don't know, not great. But the idea here is that, okay, let's say this edge is the critical edge between 2 key nodes, right? Then what does that mean? That means that let's just say we want these 2 nodes to be in the final answer. Let me also double check that this is on the graph, because sometimes I do it without showing it, my bad. But also this is a good chance to hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, which is a little bit weird, but it's fine. Actually, I like it, just to be clear, but I like calling things weird because I am not smart. But anyway, so yeah, so let's say we want to say 2 nodes, right? What is the longest or what is the max score of a path that contains these 2 nodes? And I think that's the question. And we can brute force every 2 nodes. And we'll talk about the complexity in a second. But yeah, let's say that these 2 nodes are part of the answer, right? This is an assumption. And in that case, that means that, well, obviously, this node, on the one on the bottom, will have to connect to some other good node, and the one on top will also connect to some other good node, right? So that's basically the idea, right? So you brute force on 2 good nodes, and then they both connect to 2 other nodes. And of course, there are a couple of possible situations, right? For example, and here you do greedy in a way, because in that, let's say you have, you just, the cost of this will be, say, A, B, C, D. Then obviously it's just A plus B plus C plus D, right? So that's hopefully obvious. So then here, the only thing that we have to do when we brute force is that C is not D, right? Because if you have something like this, then that's no Gucci, right? If you have something like this, it's also no good, right? Like if you look at B, or you look at A and you look at B, then that's also no good. So then the idea here is so that so the idea here is then, okay, let's say if we want to keep our greedy, then we get the max of A and max of B that isn't, well, one of these constraints, not one of these other ones, right? So none of this, right? And that's basically the idea, is doing the brute force. And here, the dot process here is somewhat pigeonhole-y, maybe, I don't know, maybe, I don't know if that's the right term, but the idea here is, okay, A, right? So A, what is the max node, right? It could be B, it could be D, it could be some C, say, another C, right? So it could be B or C. In this case, we're trying to find D, right? Something that's not necessarily connected, or at least not shared between these two. So that means that for A, you have to keep track of 3 nodes, right? 3 max nodes, because one of them could be C, one of them could be B, and then that means that the third max node is going to be this one. That means that in a way, in a pigeonhole, it'll be this one. So then here now, and you use a symmetry logic on B, then for B, you only have to keep track of 3 nodes, because one of them could be A, one of them could be C, and one of them, well, the third one has to be something that's not A or C or overlapping, right? So that's basically the idea, and then you do a brute force on it. Hopefully this visualization makes sense. When I show the code, it may be a little bit sketchy the way that I explained it, to be frank. Sketchy, get it? I'm sketching? Okay, fine. But yeah, but that's basically the core concept. That's why I feel a little bit sad, because I definitely during the contest I knew how to do this immediately-ish after seeing the length equals 4 thing. And then I don't know, I've been way slow on implementation lately, so I need to do a little bit better. But anyway, but yeah, so here, this is just setting up an edge list. It is it's the first operation that I do a lot in cleaning up the list, right? Here we keep track of the 3 best adjacent nodes, right? So best, let me write this out. Best contains the 3 closest, or 3 max score adjacent nodes. So then you have all these things, and then you keep track of the cost here, and the whatchamacallit, and the actual node label here, right? So, and this is like a way, I probably could have done it using a heap, or just even sorting it and then taking the top 3. I spent a little bit of time just typing this out. I kind of, probably not necessary, but Python is also a little bit slow, so maybe this saves me time. So yeah, but basically this is just like a cascading sort type thing to keep track of the top 3. And if it looks like it's a little bit yucky, but that's fine. And I have done this before, so that's why, and then this one is just the brute force that we're talking about. I added some print statements, but yeah, and I probably could have handled the edge cases a little bit better with respect to, I just call it -1 to not use, but I probably could have handled that differently. But basically now for each node and then for his neighbor, do this thing where, okay, you do a for loop for each of the max, and as long as the max is not equal to each other, so basically this is the case where they both point to the same node. If the best is not equal to the other node, and then also the other node's other node, and if it's not -1, then we take this possible score, and the score is of course the score of the 2 nodes and their best nodes next to it. So then now you have these 4 nodes combined in a way. So this is going to be O of n, or 9 times n, because of this loop. And then, but n of course is way confusing when it comes to graphs, right? So then now let's express them in terms of v plus e. So here, this is going to be O of, so this looks like the nested loop, and it could be really easy to suggest that this is n squared, v squared, or something like that. And of course, if this is v squared, this will be too slow because it's 5 times 10 to the 4. But of course, this is actually bound by the number of edges, right? And number of edges can be only up to 5 times 10 to the 4. So, and the reason why is because if you look at these two combined, and this, every number, or technically times 2, maybe I should have actually did it the other way, now that I think about it. Whoops. But in either case, I mean, thankfully it's still fast enough. But here, that means that, let's say here, right? each edge is only processed all of one time. Technically, all of two times, or twice, because because of symmetry reasons. Because I add edges on both, but still, all of one time. So therefore, everything inside is going to be all of. So in total, this is all of yi. And then now, because we have, and you can see that this is all of 9 or all of 1, so this is all of 9 times yi, which is of course, so this is of course all of yi, right? Yeah, that's pretty much it. Yeah. And of course I knew that this was gonna be fast enough, except for maybe some constant weird issues, which in Python and Leetcode you never know, but thankfully this passed. And in fact, like I said, I actually did double the work by accident. So yeah. So this code is very short and simple, and this is how people got it in like 5 minutes. I probably should have done it a little bit faster. Oh yeah, I got a one wrong answer here just to talk about it, because I initially only had 2 things, so I got the pigeonhole wrong because I don't know, I just messed up one case. But after I added this, it was good. Yeah. Let's show the code again in one page, maybe. Yeah, that's pretty much all I have. So let me know what you think. Oh, and of course, this is also linear space, where linear is v plus e because of this thing. And of course, this is also v plus e technically, not just O of e, because v can be, or nodes can be way bigger than e, and that would take all of v time, right? But yeah. That's all I have. What you could watch me solve it live during the contest, including the silly mistake. Now, this could be a lot. Okay, wasn't super confident. Like I was okay, but not super confident. I don't know. Okay. Undirected graph. Okay. So each one has a score. This I even mean JSON notes. Zero, 1, 1, 2, 2, 2. Let's see the n is okay. Why do we need to see length 4? Oh, huh. This feels so hidden, but I mean it's fine. But what can I do? Oh no, I guess it's just not long enough. Someone already got it. Restart. For each edge. That could be a little tricky because it's not a tree. But Don't know that I know this one, but how am I doing on time anyway? Doing okay. Could be really expensive read to just brute force, obviously, maybe. And it's pretty big. Does the ordering matter enough? For every 4 notes, I guess that's not good enough. We have to do a little bit better. Can I do? Even DP is pretty slow if we don't be careful about it. Someone already got it though. So on an edge you can do, but you have to make sure that it doesn't go to the same one, right? That's the tricky part. And okay, now so for each node, that should be linear and the number of edges. Okay, I think that should be fine. Oh, good job. 5 minutes, huh? I have to step it up a little bit, but okay. I think I could add it, but it's tricky. Maybe. Okay. Is this 0 indexed? Okay. Represent this. I know how to do this. I know how to do this, lad. Come on, focus. No. Actually, what I want is a pen. This is greater than. equals 0. That's true. Okay. 99841. Yep. Okay. I need to. Wow, a lot of people got it. Okay, well, I gotta hurry up a little bit then. I mean, it's fine. Slow down, make sure you get it right. Is this right? This is roughly right. Okay. Okay, yeah, I think this is right. Okay, let's go. -1 is proof it doesn't exist. Messed up on the phone. And that's only if and best of usable. Something like that. Okay. Otherwise. Oh, okay. Maybe that's why I needed one more. I guess I need to write this a little bit differently. 2235. That's wait, I get it right. Got the first one right. The second one's not right at all. Oof. Okay, that's good that it is not right, right? Oh, it doesn't print that much. Okay. 1311. is this -1? I forgot about -1. Okay, so that's good. The question is this fast enough? Should be fast enough. This is linear. YOLO submit. Maybe could have tested a little bit better. Oh, wrong answer. Huh. Maybe this if statement is a little bit too weird. Oh, good job, Alex. So Alex's name really quickly. But okay. My pencil. Draw this out. 0, 2, 0, 3, 0, 4, 0, 5, 6, 7, 2. Okay, so why is this? This definitely should have an answer. Is it just that? Did I mess it up? Did I do the same? Maybe I need another one. Because print best. Okay, so okay, 14 and 2. Oh, I see. So they both won each other. Okay, I should have done better on this one. I could prove this one, but oh, I messed up on the. I was thinking about this one, but it's just sad, I guess. What was the answer? 44. Okay. Now we'll see if it's fast enough. I was thinking about this, but I think I prematurely optimized a little bit. See if this is yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problems. Happy holidays. There's happy Easter, happy Passover, and happy Ramadan, happy Thai New Year, and probably missing a few. Let me know if I missed them in the comments. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.